Hello, dear young minds. Welcome to PhysicsPoint. Motion 3, we have reached at the concept of scalars and vectors, right? I told in the second video I'll be coming up with new video with the scalars and vectors, right? What are the difference between these scalar quantity and vector quantity, right? Scalar quantity and vector quantity. I will take you to this journey. All right, let's see some of the differences. What are the main differences? First of all, scalar quantity means it has magnitude. All right, it has a magnitude and it has a direction also. Magnitude also, sorry, there is magnitude and there is no direction. There is no direction for this. Magnitude means it is just a number, okay? Some number it is. I will tell you what is that magnitude, some number. Vector quantity means it has a magnitude. Magnitude means some numerical value. All right, that magnitude is there and direction is also there. Direction is also there. That is a major difference between scalar quantity and vector quantity. If somebody asks you what is a scalar quantity, you have to say it's a quantity with only magnitude and no direction. All right, if somebody asks you what is a vector quantity, it's a quantity with the magnitude as well as direction. All right, now let us look at some of the examples. Okay, these examples directly won't understand. For example, scalar quantity is a distance. All right, now if you take example here, the vector quantity is displacement. Why displacement is vector quantity? Will come to that. Okay, scalar quantity is work. Okay, work is scalar quantity, and here force is vector quantity. Like that, you have so many other things. Okay, for example, pressure is vector quantity. All right, velocity is vector quantity, and then we have acceleration, this is also vector quantity. All right, now if you come to scalar quantity, distance, work, speed, length, area, all these are scalar quantities. Now you must be wondering, what is this magnitude and direction? All right, if you take the the help of force here. For example, if I make a statement, he applied a force of 4 Newton. If I say whatever this 4 is there, no, so this 4 is known as magnitude, numerical value, number. All right, this Newton is like unit, we know about that. All right, and 4 Newton where? 4 Newton where and how? Where and how? He pushed it. Okay, you must be saying he pushed it or he pulled it. All right, for example, there is an object here. Okay, it's an object here. Now if it is being applied with a force of 4 Newton like this, so what does it mean? It is pushed, correct? Now this object is pushed. All right, so this is called as pushing. Now same object is there. Now if you are applying a force like this, now look at this. Now what is this? This is called as what? Pulling. Now do you think this 4 Newton whatever I have applied here and I applied here, both will have different effects, no? So pushing means it will move forward, pulling means it will come along this direction, no? Are you getting my point? So both are going to have different effects. So that's why direction is of a great importance in some of the quantities. When you take the force, how you are applying that force is very, very important. All right, let us look with some more examples. Now listen to me. This is a diagram what I have taken here. For example, you are standing here. You are here and let us take this is your uncle's home. Okay, this one is your uncle's home. Okay, this is your destination, or simply call it as a destination. Let me mark with red color only. This is your destination. You want to reach to your home. For example, you called your friend who is here, whom you want to meet. How your friend will guide you? Tell me. If you tell your location that there is nearby, there is a tree and there is a red car passing by. All right, so how your friend will guide you? Your friend will say, come 200 meter straight. 200 meter straight you come. Okay, after coming 200 meter straight, you will get a circle here. Okay, circle as in four roads are there, no? 1 2 3 4. This is also fourth road. Four roads are there. Your friend will say, in the circle you take right. Okay, you take right and come for another maybe 10 meters. When you come for 10 meters, so whichever house is there towards your left, that is my home. All right, so what is being told here? 200 meter. I mean 200 meter, whatever I have mentioned, this is distance only. But if you say state, 200 meter state, then it becomes what? So whatever 200 meter state I have mentioned here, this has become displacement now, because it is the magnitude 200 meter you have mentioned here, and state you have given some direction. Then afterwards, what will you say? You will say take right. Take right, you are mentioning the direction, take right. Then afterwards, he's saying 10 meter towards right. Okay, take right as in 10 meter towards right, both are same thing. Okay, 10 meter towards right. So this is like 10 meter whatever is being mentioned here. So this is a magnitude, and right whatever it is being mentioned, no, so whatever this right is there, so that is a direction. Then again it becomes what? Again it becomes displacement. All right, I hope you are able to understand what I'm trying to say. So along with some numerical value, if you are mentioning the direction, that becomes vector quantity. Here we have mentioned, no, 4 newton pushing, 4 newtons pulling, correct? No, if the force is applied like this, if the force is applied like this, 4 newton upwards. If you are applying a 10 newton like this, 10 newton rightwards. If you are applying 100 newton like this, 100 newton downwards. And if you apply 150 newton like this, it is 150 newton leftwards, towards left. All right, so directions are very very important when we are talking about vectors. Now let me give you one simple example. For example, there is a person A and there is person B. Okay, there is person A and person B. I mean, this person wants to score 98 percentage in the exam, and even the person B wants to score 98% in the exam, correct? So whatever this 98 percentage is there, no, so this 98 percentage, in both the cases it is known as what? This is known as magnitude. All right, 98 percentage is magnitude. Now if I ask a person A how you are going to do it, how you are going to score 98 percentage, he will say, I don't know. I don't know how I want to score it, how I am going to score it, I don't know, but definitely I want 98 percentage. All right, but if I ask the same question to person B, how you are going to score 98 percentage, this person will say like, sir, I will attend class. Okay, I will attend class. Okay, I will take proper notes, take proper notes, correct? I will take proper notes. Then I will solve question papers, previous year question paper. Then I will follow all instructions. So whatever instructions are given by the teachers, I will follow all of them. Then I will work very hard. Okay, I will work very hard. Then definitely by doing all these things, okay, by doing all these things, whatever things are there, by doing them, I am going to score 98 percentage. All right, so whatever this 98 percentage is there, by doing all that I'm going to score 98 percentage. Now look at this, what is the major difference between this person A and person B? This person A has a magnitude of 98 percentage, but no direction. No direction. I mean, how to get that 98 percentage? So he don't know. So that's why this person A becomes what? A scalar. He is a scalar because he has magnitude but no direction. But how about this person B? This person B becomes a vector because he has magnitude of 98 percentage and he knows how. How means direction also he has. Okay, this person B has a direction also. That's why he becomes a vector quantity. So that's why in our life, dear children, tell me what we should become. We should become a scalar or a vector. Definitely your answer will be we should become like a vectors because we should have directions. All right, I mean vector is nothing but it is just one magnitude with some direction. All right, now here is again complicated case. Okay, for example, you are here, you are stuck up here. Okay, you are stuck up here, you are standing like this. Okay, this, I mean, facing towards this car, you are standing here. All right, now you are confused whether your friend's home is this side or this side or front or I mean backward, where it is, you are confused. Now you call your friend and you ask, okay, where is your home? I mean, if your friend says where you are standing from there, it is 150 meter. 150 meter, where will you move? here or here. We don't know that, no? So along with this, you need direction. If he says 150-meter straight, 150-meter straight means it is quite clear to you. So you will just cross the zebra crossing and you will go and you will find that after 150 meter, you will find your friend's home here. So here is your friend's home. So this direction is there, no? That is very, very important. All right. Now if you come here again, the situation, it was simple case, no? Now a little bit complicated and more complicated case is here. For example, you are here now. For example, you are at the school. Okay, your school has the last hour is over now, the school is left. Now you want to have some food. Here is the food court. If you want to go there, how your friend will guide you, how the bus will take you, tell me. The bus will go like maybe 100-meter straight, then it will take the semicircular turn. Look at this is a semicircular turn, maybe of 500-meter. Then again a right turn is taken, and they may go for another 150-meter, and right of the bus, you will get the food court. Look at this, 100-meter straight, 100-meter straight, 500-meter semicircular, in semicircular. Then afterwards 150-meter towards right, you are mentioning all directions, no? So that's why these things become vector quantities. All right, one more case I have given here. For example, you are here, this is your point A, you are at point A, and if you want to reach at point B, again it is more complicated case. You need a lot of directions. So in these cases, what will help you? Google Maps. Okay, everybody must have seen Google Maps. Google Maps will be saying, what it will be saying? 2-kilometer straight. You have to travel 2 kilometers straight on NH17. Have you observed these kind of things? Then it will be saying right onto 500 meters ahead. Okay, 500 meter ahead. Take U-turn. So whatever these things are mentioned here, no? So these things are whatever, for example, a state on NH17, right onto, take U-turn. So these kind of things, whatever these are there, these are the directions which are very, very important. All right. For example, let me give you one more real-time example. For example, this is a circle in your hometown. All right. It leads to 4 roads. 4 roads like this. All right. Somewhere, somebody has deposited, as in somebody is hiding some gold here. Okay, some gold here. All right, some gold. Okay, that you got to know that the gold is there at a 200-meter from circle. Circle, as in you will be having so many circles in your hometown, no? Shivaji circle, or maybe Jawaharlal Nehru circle, Gandhi circle, like that. So many circles will be there. 200-meter from the circle, where you are going to find 200-meter from the circle means, you have to find this entire 200-meter range. Okay, this circular part, everywhere you have to find. So 200-meter from this point, this is also 200-meter, for example. Okay, here also you have to dig, 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 everywhere you have to dig and you have to search. But if just information is given like 200-meter from circle towards right of it, so then you will go directly here and you will dig at this place. Okay, you will dig here and you will get the gold. So it is just, your task has become easy just because of this direction right of it. All right, so that's why what I'm trying to say is this direction is very, very important in explaining the concept of vector. Okay, scalar means it is just a quantity with magnitude but no direction, but vector means it is a magnitude as well as direction. All right, I hope the concept of scalar and vector is quite clear to all of you. All right, and then how this scalar is represented, that is there in 11th class. Not representation of scalar, representation of vector. I will just give you a hint of that. Representation of vector. Vectors are represented like this. Look at this. They are represented like this. So this is the tail. So for example, OA I have written, no? So OA, so this is mentioned as OA, and on that there will be one arrow mark given. Okay, these all things will be studied in 11th class, no need to worry about that. This is read as a vector OA, vector OA. So this OA will be having some length. Let me take that as A. So this can be written as a vector OA is equal to A. Also we can write it. All right, so whatever this A is there, no, so this A is known as magnitude of vector. What is this? Magnitude of vector. So magnitude of vector is given by, magnitude of vector is given by length of vector. So whatever this length of the vector is there, no. So for example, I write two vectors. One vector is like this, another vector is like this, which is a bigger vector. Both are having same directions. For example, if it is a 4 centimeter, means it may be 8 centimeter. So whatever length is there, so length of the vector is there, no, so that represents what? Magnitude. All right, so this O is called as a tail. O is called as tail. A is called as a head. If I write any vector like this, okay, here is the tail and here is the head, and I can name it anything. I can name it as AB. AB means it may be having length of x also, so we are going to represent it as a AB vector is equal to x vector. All right, both are same things. Now coming to directions, definitely you must be having direction knowledge. So this is towards north, and this is towards the south, and this is towards east, and this is towards west, and this part is known as what? Northeast. All right, and this part is known as what? Northwest, and this part is known as southeast, and this part is known as southwest. All right, majorly there are 8 directions. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so for example, if I write any vector like this, so 4 meter if I write, so this vector is a 4 meter towards northeast. Look at this, 4 meter towards northeast. Look at this direction, this is northeast, no? So that's how we are going to represent. If I write something, a vector like 10 meter like this, so it becomes what? A 10 meter south. Okay, whatever this arrow mark is there, no, so this arrow mark, this head is there, no, the task of this head is to show the direction, in which direction it is going. If I write anything like this, for example 10 Newton, okay, this is the force, means 10 Newton, what it becomes? It becomes northwest. All right, I hope the concept of scalar and vector is quite simply understood by you, and there are so many things. There is a separate chapter called vectors, okay, in 11th class. Okay, that name of that chapter is a motion in plane. Motion in plane. All right, so we are going to study about that motion in plane or vectors in the further classes. All right, so I hope the things are understood easily. If you are finding these videos useful, support us by giving it a like. All right, I mean, whatever improvements you want, you can just comment down, and don't forget to share these videos with your friends, and comment down what you want to listen from us. This is just a simple like for you, but it means everything for us. All right, share it. It doesn't take much time to share the good work, and comment down, and don't forget to subscribe to the channel, because this is the main motivation which keeps us going to make more videos like this. All right, thank you very much. Have a good day, and bye bye.